Good morning, everyone, and welcome to Thursday's maths lesson. I can investigate angles in a polygon. So here's our first problem. Let's have a look at those three shapes. So first of all, what is the shape in step one? Well, hopefully you've all guessed that that is a rectangle. So it's got two pairs of parallel lines and four equal angles, and each angle is 90 degrees. So then we've cut off a piece of the rectangle, we've cut off a triangle, and the angle we have made our cuts at is 60 degrees. So what shape is left now we've taken that triangle away in step two? That's right, it's a trapezium, a special type of trapezium called a right-angled trapezium. Then you've got step three. Now we are cutting off another identical triangle. So both the triangles that we've taken off are the same size. So what are we left with? We are left with an isosceles trapezium. So let's think about the properties we've got here. Well, as I said with the rectangle, we've got two pairs of parallel lines and four equal angles. With a trapezium, we only get one pair of parallel lines. With an isosceles trapezium, we get one pair of parallel sides and adjacent angles are equal. Let's have a look at that a little bit more detail. So here we go. There you can see in step one, that's our rectangle. Can you see the arrows there? Where you've got one arrow, that tells you that those two lines are parallel. That's your first pair of parallel sides. Where there's two arrows, that shows you that that is your second pair of parallel lines. And there you've got your four right angles, sorry. So 90 degrees plus 90 plus 90 plus 90 means that the interior angles of the rectangle add up to 360 degrees. Now, remember that we've cut away a triangle. We know that it is 60 degrees at the bottom that we've cut away. Therefore, because angles on a straight line add up to 180, and we already know that, the other side of that angle must be 120, the one on the inside. If we look at the top corner there, we can see that it was originally a right angle. If part of that is 60 degrees, then the other side must be 30 degrees, and vice versa. So our interior angles, 60 plus 120 plus 90 plus 90. So once again, our interior angles of our quadrilateral equal 360 degrees. Now our final step, we've made an isosceles trapezium. Can you remember what the properties are for an isosceles triangle? That's right. It's got two equal angles and two sides that are the same length. Well, the single line on those two sides, again, just like in a triangle, show us that those are the same length. And with an isosceles trapezium, we have adjacent angles are equal. So those angles at the top that are next to each other, they're both 60 degrees. And the angles at the bottom that are next to each other, they're both 120 degrees. So let's add them all up. 60 plus 120 plus 60 plus 120. And once again, all those angles add up to make 360 degrees. So we can write a new generalization today, and that is interior angles of a quadrilateral add up to 360 degrees. So we've cut off our two identical triangles. What can we work out about them? Well, we know that one angle is 60 degrees. We know that there's a 90-degree angle, and we can work out that the other angle at the top is 30 degrees. How do I know that? Because 90 plus 60 plus 30 equals 180. And of course, we all know now that interior angles of a triangle add up to 180 degrees. So if we forget about the trapezium we've got left and just look at our two triangles, if we put them together, what sort of shapes can we make? I'd really like you to have a go at this, getting a piece of paper, a rectangle, and cutting those off. You can get two different types of triangles and three other quadrilaterals. Have a go, pause the video, and then have a look and see what we do on the next slide. So how did you get on? We can put our triangles back together to make another rectangle. So again, our interior angles add up to be 360 degrees. We can also put our triangles together in two different ways to make two different parallelograms. And if you look at the angles there, you can see again that they all add up to 360 degrees. And I did say as well, didn't I, that we could put them together to make two triangles. What type of triangles have we made? Yep, we've got one isosceles and an equilateral triangle. So let's remind ourselves about our generalization. Interior angles of a quadrilateral add up to 360 degrees. So I definitely want you to have a go with this one, with another piece of paper. So we've got a rectangle this time, and we're going to chop off the same size triangle as we did before. So we know that the angles in that triangle are 60 degrees, 90 degrees, and 30 degrees. But this time, when we've made our second cut, our triangle is the other way up. So what shape have we got left? We want to have a think about that angle there. If we know that the other side of that is 30 degrees, but our angle of our rectangle was 90, we can work out that that interior angle is 60 degrees. And it looks like here we've got two pairs of parallel lines. So I can also work out that the bottom right corner, the interior angle there, is also going to be 60 degrees. So opposite angles in a parallelogram are going to be equal. If all the interior angles add up to 360, and we've got two that are 60 degrees each, we can work out what the other two angles are, can't we? 60 plus 60, which is 120, and then take that away from 360 degrees. But don't forget, you've got two angles, so you'll then need to divide that by 2. Let's have a look at this question. So in A, we've got two pairs of parallel lines. So that means it has to be a parallelogram. Can you remember what I said about the angles inside a parallelogram? I said opposite angles are equal. So if we know that the left-hand bottom corner is 75 degrees, then that means the one opposite to that, so the top right corner, that's also going to be 75 degrees. And from that, you should be able to work out what the other two angles are. Now, B, the first thing to think about is what type of shape is it? It has one pair of parallel lines and one pair of sides that are equal in length. So because it's got one pair of parallel lines, we know that that's going to be a trapezium. And the fact that we've got two equal sides, that means it's going to be an isosceles trapezium. Can you remember what I said earlier about the angles in an isosceles trapezium? Adjacent angles are equal. So if the top left angle is 115 degrees, then the top right angle will also be 115 degrees. In C, you know what three of the angles are, and of course you've already remembered that interior angles of a quadrilateral add up to 360, so you should be able to work out what that fourth angle is. And D, what shape is D? It's a parallelogram again. Have a think back to what I said about the angles in a parallelogram. So now you're in your practice book. Question 1. It's asking you to join the shape to the right name. Don't worry about drawing the shapes out. Just write A and then write the name of the shape, B and the name of the shape. You can see by the labels, we've got three types of trapezium and one parallelogram. So I would go and work out which one the odd one out is. Which one's the parallelogram? Remember that the parallelogram has two pairs of parallel lines, whereas a trapezium only has one pair. That should help you get started with that one. If we look at number 2, the following shapes have been made from rectangles. Calculate the missing angles. So in A, you need to remember that angles on a straight line equal 180. So if we look at the top right angle, we know it's 70 degrees from the straight line to the outside of the parallelogram. So 180 minus 70 would give you that interior angle. Opposite angles in a parallelogram are equal. So you should be able to work out the one that's at the bottom left. In B, you've got a trapezium. What do we remember about a trapezium? We remember that adjacent angles are equal. In question 3, add markings to show all the parallel lines or equal lines in the shapes below. So you're going to have to redraw these. You'll need a ruler or a straight edge to do that. Remember, to show they're parallel, you put an arrow, and to show they're the same length, you just put a line. Question 4 is calculate the missing angles. Again, rewatch the video if you get stuck with this one. And question 5 asks you to decide if a statement is always true, sometimes true, or never true. So you're going to want to draw some pictures. Can you draw a parallelogram that has 3 acute angles? If you can you draw more than one of them? Does it always work? And the same with a trapezium. Can you draw a trapezium that has 4 different angles? Can you do that more than once? Have a go, and those diagrams will help you prove whether it's always true, sometimes true, or never true. Then if you fancy, we've got some challenges there for you. If you're still thinking, oh, I'm not too sure, then have a go at these as well. And then we need to do our reflection. So draw a diagram to explain what you know about the angle sums in trapeziums and parallelograms. Remember what our generalization is, And then you just have to explain how you know that's true. Finally,